In this tutorial, I'm going to draw an isometric drawing of building 1 in a different method. So in the last video we used isometric drafting, which is this function you can find on the lower bar, to draw a fake 3D drawing of an isometric projection. The method we're going to do in this tutorial, however, is going to be, we're going to create a 3D modeling using the extrude command, and then having the 3D model, we're going to set the view to an isometric view. So it's a different process. I'm going to start with the same plan that I did in the last video. So I'm just going to make a copy, place it down here. And remember that when I drew this plan, I created 3 separate closed polylines. So each one of these shapes is a closed polyline. Even this one, it goes around the building like so, all the way around using a closed polyline. If you need to remember how to create a closed polyline or how to close an existing one, please watch my video on creating and editing polylines. So now that you have your plan view, I'm going to switch to isometric view. You can do that by clicking on the corner of the cube inside your compass. Right there, it's highlighted in blue. Or going back to top view, you can also enter isometric view by clicking up here where it says top, click and change to one of these 4 isometric views. These 4 views match the 4 corners of the cube. So it's the same thing. It'll take you to the same place. So pick the view that you want to create or that you want to work with. It's going to be a 3D model, so we'll be creating all 4 views. So pick one that you want to work with, and when you're ready, we're going to select let's select the taller volume, which is this bigger one. Once it's selected, I just left clicked on it to select it. Type the extrude command. The shortcut is EXT, enter. Sorry, let's try that again. EXT. There we go. When you enter the extrude command, it's going to give you a preview of what it's going to do. If you point to the negative portion of the blue axis, the z-axis, or the positive direction of the z-axis. Now we're not going to click, we're going to enter the exact height. So we're going to point up, and I'm going to type in 40 feet, enter. That's 40 feet tall right there. And we know that the other 2 volumes, and I can do them both at once, select them both. Remember, they are closed polylines. This will not work if you don't have a closed polyline. But if you do, you can select multiple at the same time. Select them, go back to the extrude command, enter, EXT, enter. And this one, we're going to point up and type 30 foot, enter. And that gives me a 3D model. These are no longer polylines, they are 3D solids, each one of them. So I have 3 of them. And I can go to the visualize menu at the top of the ribbon and change the visual style from 2D frame or 2D wireframe to any of the other visual styles. Now, some of these will not work or will not appear to work. They will work, but they will not appear to work. For example, if you choose one of these like realistic or shaded, they will all look the same. And this is because these visual styles depend on rendering to show the actual textures. So these will show once you render your 3D model, which I'm not going to cover in this video. For this tutorial, I'm just going to choose the hidden style. And this is similar to wireframe, except that it hides everything that is behind it. One more thing that you can do, if this is the case, in the lower right corner of the visual styles portion of the ribbon, you can turn on the Visual Styles Manager. And if you select the visual style that we're using, in this case, it's hidden, you will see one option called Silhouette. By default, this one is turned on and it says yes, but I turned it off earlier. So usually it will be like this. It will say yes. And what Silhouette Edge does, it highlights the silhouette of your object, just like so. You can control the line weight of that silhouette with these numbers, or you can turn it off entirely by changing this yes to a no, which is what I had before. I like to turn it off. So I'm turning it off and I'm closing the Visual Styles Manager. And now I have a 3D model of the building, which I can then use to select any of the 4 isometric views, whichever one you need, and hit escape to release the selection. And let's go back to our layouts. And now I'm going to copy this layout to create another one. Move to the end, create a copy. So I have a third layout with the same page size. And in this layout, where I had my orthographic isometric, I'm going to find my 3D model, which is this one. And I'm going to switch over to an isometric view. Remember, select the object and then use the compass so that it pivots around your selection. So I'm going to use that one. Double click outside. Now, the main difference of doing it this way is that if I scale this, drawing to the same scale I had on the other ones, so my plan is 1 inch equals 30 feet. My isometric drawing that I did in my last tutorial video is 1 inch equals 30 feet. Same scale as the plan, and I use the actual dimensions. So what I measure here, any measurements that I make here are going to match what's on the plan. There's my 270 feet long for the long building. However, in this new drawing that I made in this tutorial, the 3D model, even if I choose the same scale, 1 inch equals 30, this is now an actual isometric view of the model. It's not that fake isometric drafting that I did before where I used the actual measurements. This one has the actual measurements, but it is now seen in isometric projection, actual isometric projection, which causes foreshortening. So any measurement here, let's measure that same length of the building I measured in the past layout, which was 270 feet in the other one. It is now 220 feet in this one. So anything in this isometric projection is going to suffer foreshortening along all 3 axes. My heights are going to be less than they should be. So this 40-foot long or 40-foot tall building from here to here is now going to actually measure 32 feet. So you're going to get foreshortening everywhere. And there is no easy way to fix that. The really complicated way that I tried to explain in class this morning was because I knew it was going to shrink to 82% of the original. What I tried to do in class was I enlarged this one by the same factor that I knew was going to shrink when I changed to isometric view. And it's really complicated and it's easy to get the math wrong. And even if you do everything right, you're going to have a little bit of rounding error, so it's never going to be quite the same. For that reason, I highly recommend that if you need an isometric with measurements, do it using isometric drafting, this tool down here that we covered in the last tutorial. If you don't need measurements from your isometric and you're just illustrating an isometric view, but you don't need to measure anything, which is the situation in most isometrics, by the way, then use a 3D model, because the 3D model is going to let you get several views from your work. You model the building once and you can generate many views from the same one. So that's the advantage of doing it this way versus if you do your isometric drafting, you can get actual dimensions, but you don't get, this is not a 3D model. So this is not going to show you any other views. This is just one flat view that is only seen in top view. But the advantage of this one is you can get those measurements. So if you draw things like construction details in an isometric view, this is a good way to do them. If you're just demonstrating like a spatial diagram, a diagram of your project where you don't need to make any measurements, you just need to show the space, this one is more advantageous in that situation. Okay, that's the end of this tutorial. That's now 2 different ways of drawing an isometric projection in AutoCAD.